All right, so what is an instrument? We want to use instruments to be able to split our policy variables into the exogenous part and the endogenous part. But how do we actually do that? At the end of the last slides, I showed that the way you do that is with an instrument. But what is that? So an instrument is just something that you can measure out in the world that meets three special criteria. The first is it's something that is correlated with your policy variable. It is something that causes more education in our education and earnings example. The shortcut term for this is relevance. It's something out in the world that causes your policy to happen. There are lots of things that cause additional education, but the tricky part of an instrument is that it has to also meet this criteria. It has to be something that does not directly cause the outcome. This is called the exclusion principle, or it's something, this instrument only causes higher wages because it causes education. If there are other paths to boosting your wage outside of education, then it's no longer an instrument. It has to only go through your policy. So again, the instrument causes the policy to happen or is correlated with the policy. The instrument causes the outcome, but only because it goes through the policy. And that is the exclusion principle here. And the last thing is it has to itself be exogenous. It has to not be correlated with any of the omitted variables or anything in the error term. And so this is the exogenous or exogeneity principle. So it has to meet all three of these characteristics. It has to be something that is relevant, something that meets the exclusion principle, and something that is exogenous. And if it can do all of those things, then it is an instrument and that you can use to split your variable into endogenous parts and exogenous parts. The relevance aspect of an instrument is testable with stats. You can run a regression and see if your instrument is correlated or related to your policy. And if it is, hooray, you have relevance. The exclusion principle can kind of be tested with stats. You can run a regression to see if your instrument causes or is related to your outcome. But the fact that we have to prove that the instrument only causes the outcome because it goes through the policy, that there's no way to test that with a regression model. You can't type anything magical in R or in Stata or SPSS to see if something is exclusive and meets the exclusion principle. There's no way to do that. That's purely theoretical, and you have to justify that it does that. The exogeneity principle, that also there's no statsy way of measuring that. If you have a well-drawn DAG, you can point to the DAG and say, it is exogenous, and there's no arrows going into it. If you don't have a DAG, then you have to spend paragraphs explaining why it is exogenous, why it meets the exclusion principle. And it can be hard. And this is where instrumental variables gets the trickiest, is because lots of instruments that people find often don't meet this exclusion restriction here, where the instrument, whatever it is, can only cause the outcome because it goes through the policy. And that's the trickiest part about all of this. So again, I'm going to repeat it so you can remember this. The relevance thing means that the instrument is related to the policy. It has some sort of causal effect on the policy or some correlation with the policy. The exclusion principle is that your instrument is related to the outcome, it causes the outcome, but it only does it because it goes through the policy. And there's no other way to get from the instrument to the outcome unless you go through whatever your program is or whatever your policy is. So keep that in mind as we talk about these things here. This is helpful if we look at a DAG again. So if we look, we've seen this triangle before. You have an outcome, you have some program that causes the outcome. We have these unmeasured confounders that we can't actually measure the effect of the program and program and policy on the outcome because there's endogeneity. But if we can use an instrument here, which is wholly outside of the rest of the DAG here, it's something that causes the program, but is not caused by any of the confounders, The outcome itself doesn't cause the instrument. It's just kind of this external thing that causes the program. So that's relevancy right here is this arrow, but also causes the outcome, but only through the program. So you can see that because there's two steps here. You go from instrument to policy, and then policy to outcome. The only way to get a causal relationship between instrument and outcome is through this policy. There's no other arrow that goes directly from here to outcome or from here to a different node to outcome. And so this is the instrument in a DAG. So if we look at the education example we've been talking about, we have education and earnings. We have this unmeasured ability, but we also have this potential instrument here, which is father's education. And back in the 1990s and 1980s, when instrumental variable models were being developed for questions like this, father's education and mother's education were super popular instruments that everybody loved to use because arguably you could say that your father's education causes your education to some extent. Your father's education causes your earnings and influences how much you earn, but it's only because of the education that you received. That was the argument back then. It doesn't really hold up at all. There's a whole host of reasons why if your dad gets a whole bunch of education, that's going to have some influence on your earnings outside of this education node here. And we'll look at examples of why that's bad. But for the sake of this argument here, just pretend that the only way your dad's education will influence your wage today is through your education. So pretend that is true. If we can do the DAG like this, and if that black node right there for the instrument is true, that instrument will remove the endogeneity of education. Then the education that's left in our DAG is just the exogenous part of education. Ability is still unmeasurable, but that's okay because by using father's education to separate out the endogenous and the endogenous part of your education, we don't need to worry about that unmeasured confounding because we've split education into kind of these magical two parts. And so we're only looking at the exogenous part of education, and so that will be our causal effect on earnings. So that is why we do this here. Okay, so we're going to walk through each of these conditions that you need to have for a good instrument: relevance, exclusion, and exogeneity. And we'll look at specifically some other examples that have existed in the world here. So with relevance, again, this means that the instrument causes the policy or has a strong correlation with the policy. Here are some common instruments that people have proposed for measuring the effect of education on wages. Social Security number is totally unrelated to wages. It's an outside node inside a DAG. It's kind of a weird thing. But it's probably not relevant. Your Social Security number does not make you earn more education or get more education or get more school. It's kind of randomly assigned. It's not entirely randomly assigned. There are actually patterns to the assignment of Social Security numbers based on the county that you were born and the month that you are assigned your Social Security number. So there are some trends, and you can kind of track where people were born based on the first few digits of people's Social Security numbers. And so potentially you could say that it's related to education, but it's not really that apparently relevant. And so Social Security numbers don't really cause education. Third grade test scores could potentially cause more education. If you get early grades that are good in third grade, then you're probably going to get higher grades in high school and then higher grades in college and probably get more education. And so that meets the relevancy criterion there, where early grades cause more education. Father's education, on the other hand, is also relevant, where if you have educated parents, it likely causes you to get more education as well. And so that is also a relevant instrument there, where there's a direct relationship between father's education and your education. And so we can call all of those things relevant. or these two things relevant. We can't really call social security number relevant because there's no direct relationship between your social security number and your education. The next thing we want to look at is exclusion. So this is the only through condition, where the instrument only causes the outcome, or wages, because of education, because of the policy. So if we look at these three potential instruments again, we have our social security number. Does that only cause your wages because of education? Potentially. This is where it's tricky. It's not really, like, we already said that there's no relevancy. The social security number does not cause you to get more education, but we could pretend it does. If we say that your social security number, based on, like, if we see patterns in social security numbers and some counties have less education, then we do have a relationship there. But then we could also say that the social security number is not correlated with your wage, except through education, if there's that relationship. But that's not really great, as we've looked at. With third grade test scores, this is potentially exclusive. So we already said that early grades cause more education. For exclusion to work, we have to say that early grades in third grade cause more wages later on, but only because it made you get more education. If we can tell that story convincingly, that your third grade test score made you richer later in life because you have more education and only because you went to more school, then we can say it meets the exclusion principle. But that's a tough sell. Father's education, this is a third potential instrument here. If we want to talk about the exclusion principle for father's education, we have to say that your parents' education causes you to have higher wages, but only because it makes you go to school more and makes you get more education. There's no other path between your parents' education and your wages. If you can tell that story convincingly, then you meet the exclusion principle. If you can't tell that story convincingly, if there's something else that links your parents' education with your wages that's outside of school, then you can't use it as an instrument. And nowadays, nobody uses it as an instrument because there's a whole host of things that also link the two. In the 90s, they didn't believe that, and so they just stuck with parents' education because they thought it was fine. Exogeneity, the third principle here. This means that the instrument is independent of all other factors. It's basically a random assignment, something weird that happens in the world, and there's no other arrows coming into it in the DAG. Social security number, one reason people love to look at these things is because it is super exogenous. It's not related to anything related to education or wages. It's just kind of a number that the government gives you that's super exogenous. Third grade test scores are definitely not exogenous. Your grades in any grade, third grade or 12th grade or whenever, are correlated with a whole host of things that also cause more education. And so it's not really exogenous. There's arrows coming into your third grade test scores, and so it doesn't really work. Father's education is, back in the 90s, was exogenous because the birth to your specific parents was random. The birth to your parents, there's no arrows coming into that. It just kind of happened, and so if you believe that story, that the choice for your parents to get more education and your parents to have you, if that's a fully exogenous story and there's nothing else influencing that, then you can call it exogenous. And in the 90s, they did. And so lots of examples continue to use this. So if we look at the DAG here, we have our father's education causing education. And if we look through the relevancy and the exclusivity and the exogeneity, we can tell a story about all of this. So again, to kind of drill this into your heads here, the relevant aspect of father's education means that there's a relationship between father's education and your education. There's a direct causal effect there, which arguably there is. Exclusivity means that father's education is linked to earnings, your outcome variable, but only because it goes through education. There's no other path between your parents' education and your earnings. It's only because of education here. The exogeneity part of this means that there's no arrows pointing into father's education here, that it stands by itself. Your ability does not cause your father's education. We can't draw an arrow between that red node up at the top and this here. That doesn't make sense. We can't draw any other arrows into this instrument here. It stands alone. And the fact that it stands alone means it's exogenous, and so we can go with that. So we can arguably, if we lived in the 90s, say that this is a good instrument because it's relevant, exclusive, and exogenous. The reason it's no longer a good instrument is because, in general, if there's a plausible story for kind of breaking, like if it seems logical that your father's education would cause more earnings later on in life, if you told anybody on the street, like, I want to know what the causal effect of your parents' education is on your earnings, that seems like a super obvious question. And the fact that it's super obvious means that it probably has a strong relationship outside of just education by itself. There's a whole host of other reasons why that might influence earnings, and so it's not confusing. It's not a weird thing. It's a logical explanation. As you read in the causal inference mixtape, though, one qualification for having a good instrument is this thing that Scott Cunningham calls the factor, where if you want to have a good instrument, it has to be something that makes people confused when you tell them about the relationship between the instrument and the outcome. So if we pretend that Social Security numbers are a good instrument, they're not because it's not relevant, but if we pretended that it was relevant and you told somebody at a party that you were studying the effect of education on earnings, but you were doing that by studying the effect of Social Security numbers on earnings, and that people with certain Social Security numbers had more earnings later on in life. That seems weird. That doesn't have a direct logical causal link at first. You have to explain that Social Security numbers cause specific areas of the country to get more education, which then causes wages, and it's a more complicated story. And the more complicated and weird that relationship is, in general, kind of the better an instrument it is. And so we see that if we look at other studies that have used instrumental variables, we can see how weird some of these instruments are and how common some of them are. And the common ones, as you'll see, are generally criticizable based on this exclusion principle. They probably don't meet the exclusion principle because they're too obvious. So if we look at one common way of looking at health outcomes, looking at the effect of smoking cigarettes on health, we've used this as an example throughout the semester where you can't run a randomized control trial to do this. You can kind of get at it with diff and diff if different states implement different smoking policies at different times. And so what some scholars have done is they've used instrumental variables to get at the relationship between smoking cigarettes and health. To get around this omitted variable, so if you look at this column here, there's a whole bunch of other negative health behaviors that influence health. Smoking cigarettes is one of those things. And so that's our unmeasured confounder. We can't actually measure everybody's negative health behaviors. So what we can do is we can get around this omitted variable by using an instrument. So in lots of research, people use the existence of or raising of tobacco taxes as an instrument that then explains smoking cigarettes, which then explains health. So the relevancy means that tobacco taxes are related to smoking cigarettes. That makes sense. If taxes go up, if you think about your economics class, taxes go up, smoking cigarettes goes down, depending on how elastic that relationship is. So there's our relevancy. The exclusion story is that tobacco taxes cause health, the outcome, but only through cigarette smoking. Raising tobacco taxes won't increase your health because it makes you run a marathon. That's not on the path between tobacco taxes and health. So arguably, the only way you can get from raising tobacco taxes to health is through cigarettes. And if that makes sense, then you have a good instrumental story and that works. My favorite example of a weird, confusing instrument that makes you say, huh, is this story here that some researchers have looked at to see what the effect of Americanization is on labor market success. Americanization meaning like integration into the labor market and integration into greater society, learning English, finding neighbors, incorporating your social circles into your neighbors' social circles, that kind of stuff. That's really hard to measure, first of all, just general Americanization. There's a whole host of unmeasured confounders like ability, but a whole bunch of other reasons why somebody would or would not Americanize as an immigrant or have labor market success. And so there's a whole world of omitted variables there. And so what researchers did is they found this really bizarre instrumental variable here, the Scrabble score of your name. And they found that people with higher Scrabble scores of their names, performed less well in the labor market because they were, in theory, less Americanized. And the reason that story works is because the Scrabble dictionary and the points that you get in different tiles of Scrabble are based on newspapers from the 1930s, a whole corpus of different newspapers. And then they counted up the frequency of all of the different letters in these newspapers back in the 1930s to find the most common and the least common letters. And so back in the 30s, like based on this corpus of language from the 1930s, they found that there were patterns in which letters were more common and less common, and that those letters kind of reflected the general culture of the alphabet, essentially. And when you had immigrants coming from Eastern Europe and from Russia and from Italy and from Spain, from other places that don't use the same distribution of letters, then what you get is names that look weird numerically compared to the American names that existed in the 1930s. So if you were an Italian immigrant named Giovanni, your name was spelled with a G and a V and two N's, and those are kind of higher scoring letters in Scrabble. Giovanni is John in English. The J has a high score in Scrabble, but none of the other letters do, and that's a much shorter name than Giovanni. And so what they found is that immigrants coming to the United States from other countries, if they changed their names from longer, weirder looking names that have higher scores to a shorter version that looked more American for the 1930s, what they found is that those people who changed their names and tried to assimilate and look like they were more American than Italian or more American than Latvian or more American than Russian, they had, in general, better labor market success. So the story here, if we go back to instrumental variables, we have relevancy, where your Scrabble score, how complicated and how unique your name is, causes Americanization. It causes how different you will look in greater society back in the 1930s. So there's the relevancy story. The exclusion story is that your Scrabble score causes you to have labor market success, but only because of integration into society and Americanization. That's the only way having a weird, complicated name makes you have labor market success. There's no other path. It's only through that Americanization there. And then exogeneity, your Scrabble score of your name, that's just determined by the outside world. There's nothing kind of influencing the fact that your name is Giovanni instead of John. That's just how it is. And so it meets all three of those requirements, and so it's a good, strong instrumental variable. And it meets the fourth requirement, which is that it's weird. When you tell people that story at parties, they'll be way more interested in the Scrabble, like the relationship between Scrabble scores and labor market success in the 1930s, because that's a really bizarre story, because it meets the exclusion principle. If the story is bizarre, it means you have good exclusion. Other quick examples here. One thing that lots of researchers are interested in is the crime rate in a city. And then whether or not having more police patrolling, increasing patrol hours, does that reduce the crime rate? A tricky part of that is the number of criminals in the society makes it hard to see if patrol hours are actually doing anything. It's confounding both the crime rate and patrol hours. And so there's no way to actually measure that because not everybody's reporting if they are going to do crimes that day. And so what researchers have done is they've looked at election cycles, and they found that when there are mayoral elections and gubernatorial elections, patrol hours tend to increase because politicians want to be seen as cracking down on crime. And so researchers use these election cycles to explain the crime rate. And it's because it goes through increased patrol hours. And so that's the exclusion story here, is that election cycles cause the crime rate, but it's only because it goes through patrol hours. And if you believe that story, then it's a good instrument. The relationship between education and income, we've been talking about this throughout this lecture here. Father's education, people use that. People have also used distance to university, or whether or not you're drafted into the military, because then you get VA benefits or GI benefits, and you can increase your education. And so, again, the story here is that these instruments cause more education, but and then they also cause income, but it's only because it goes through education. There's no other relationship. It's only because your distance to college makes you earn more money because it makes you get more education. So if you can plausibly tell that story, then you have a good instrument. More with crime. If you're trying to measure the crime rate, again, based on the incarceration rate, like counting how many people you have in jail, that's hard because both of those things are happening at the same time. You have this simultaneous causality. So one way to get around that is to use this instrumental variable here, which is counting how many lawsuits there are about overcrowding in prisons. And so the relevancy story is that overcrowding litigations cause the incarceration rate or influence the incarceration rate, which makes sense. If you're getting sued because of overcrowding, you're probably going to lower the amount of people in prison. The exclusion story is that overcrowding litigations cause crime or reductions in crime, but it's only because they change the incarceration rate. There's no other path between suing jails for being overcrowded and the crime rate. So if you can tell that story, then you have an exclusive relationship. Election outcomes, some political scientists have looked at this. This is similar to the crime rate and election story, where you want, if you're interested in whether or not there's federal spending in a district, if you're a congressperson and you want to get reelected, should you spend more money in that district? Does that help your election outcome? And so people have used instruments based on the total federal spending in the rest of the state to see if that explains the election outcomes, but only through federal spending in your district. So again, if you can tell that story of exclusivity, then you're good. And then the last here, that political science and international development love to use, is this idea of using rainfall as an instrument, where if a researcher is interested in civil war or in riots or violent protests, trying to figure out the causal effect of these conflicts and this civil war is hard because you can't randomize that. And so what researchers are often interested in is, does a country's economy cause more civil conflict? Does economic growth or the decline of economic growth cause more civil war, cause more riots? That's really hard to measure, and so what they use is rainfall as an instrument. And the argument here is that if there's more rainfall, then there's less drought, which then causes more economic growth, which then causes fewer conflicts. So the story here is that the instrument, rainfall, the relevancy side means that it causes economic growth. Sure, that does make sense because it gets rid of droughts or causes droughts if there's not enough rainfall. The exclusion story is that rainfall causes conflicts or reduces conflicts only through economic growth. If it rains, there's no other reason for conflicts to stop besides having better economic growth and better crop growing and other things like that. And so if you can tell that story of rainfall causing conflicts or causing the reduction in conflicts only because of economic growth, then you have a good instrument. In real life, it's not a good instrument. There's a whole bunch of research that shows that there are other paths between rainfall and conflicts, and it doesn't actually work. But people like to use it still. Moral of this story, looking at that history of all of these different instruments that have been used. Instruments are hard to find. They're very hard to prove the exclusion restriction. That's generally the hardest thing to do. You can prove relevancy. You just run a regression between the instrument and your policy, you've got relevancy. Telling a story about exclusivity or about the exclusion principle, that is hard, and that's where people run into the most problems trying to convince people about the strength of their instrument. Again, this is the idea that the policy causes the outcome, or the instrument, policy causes the outcome only because of I wrote this wrong, ignore this. It is that the instrument causes the outcome only through the policy. I will rewrite this in the actual slides that get posted. So again, the instrument causes the outcome only through the policy. Okay, and most proposed instruments fail this principle here. One good example of this is the current pandemic that we're in. The whole reason you're watching this video instead of talking with me in real life. Once the United States started going into social distancing mode and shutting down schools and shutting down workplaces and everybody's staying home, lots of economists online started talking about using this as an instrument because it's a big external shock to a social system. It's very exogenous. And so you could potentially use that as an instrument for some other relationship that you care about. And so maybe we can use it as an instrument. So if we go back to our story of education here, let's say we're interested in the relationship between school attendance and grades, and then down the line earnings. So does going to school make you have better test scores and better grades? We have a whole bunch of unmeasured confounders in students. We can't measure student ability. We can't measure a whole host of other things. But if we can use the COVID-19 pandemic as an instrument for school attendance, then we can split school attendance into the exogenous part and the endogenous part, and then we can say that we have the causal effect of school attendance on earnings or on grades or whatever our outcome is. And that at its core makes sense. We want to be able to use this weird exogenous thing to split our policy variable into two and then get the causal effect of the good part of that policy on our outcome. But the tricky part here is we have to make sure this meets the exclusion restriction or the exclusion assumption, which is that we have relevancy. The COVID-19 pandemic definitely has a causal relationship with school attendance. It has killed school attendance. But we also have to say that the COVID-19 pandemic has an effect on grades or on earnings only because of school attendance. There's no other reason you would have low grades because of COVID-19 other than the fact that you're not going to school. And does that hold up in real life? In real life, I would have you all say no, because obviously not. Here's this fun DAG here that shows a whole bunch of different reasons why you might have different grades because of COVID-19 outside of school attendance. COVID-19 causes death in families, it causes health issues, it causes job losses, it causes social isolation, causes anxiety. All of those things influence your grades or your earnings or whatever outcome we care about outside of school attendance. So yes, COVID-19 does influence school attendance, sure, but all of these other things also influence grades outside of school attendance, which means it breaks our whole exclusion principle, and we can't use it as an instrument. As fun as it would be to use this big exogenous pandemic, it's so widespread and so ingrained in every aspect of society that it doesn't actually work as an instrument at all. And so don't use it as an instrument. It doesn't work. So in general, the way you can check kind of your exclusion assumptions is to think about it in DAG language again. If you can think of some other way that an instrument can cause an outcome outside of the policy, so try to think of some node that you can add to the DAG that will change the causal story here. So if we go back to our DAG here, If we can draw something from instrument to some other point to outcome, then that breaks our exclusion assumption. So this is the question you should go through. Does going from the instrument to something else change our outcome, or lead to the same outcome? So if we talk about the rainfall and Civil War example here, what researchers have found, like again, the argument here is that rainfall causes economic growth, which then decreases civil war. And the only path that you have between rainfall and civil war is because of economic growth. But what researchers have found is that in some villages in northern India, some villages are located upstream of dams, which means they have tons of water. They have direct access to reservoirs. And so even if it doesn't rain, they are still growing stuff, and they're fine. They're more protected from droughts. And so you would think that in those places, there would be no relationship between rainfall and civil war, because if it rains a lot, you still have water. If it doesn't rain at all, you'll still have water. And so in theory, that relationship between rainfall and civil war should break. But what researchers find is that rain, for whatever reason, still causes riots and still causes protests, even in the villages that have greater access to water. And so there's something else in that DAG that we can't see that is causing that relationship between rainfall and civil war outside of economic growth. And so it doesn't necessarily work as an instrument. If we look at tobacco taxes and health, people love to use this thing. And again, the argument was that tobacco taxes make it so that you smoke less, which then increases your health. But if you think about elasticity, back in your microeconomics days, elasticity shows how responsive people are to price changes. And what economists have found is that for most people, even if you double the tobacco tax, the actual consumption of cigarettes stays about the same. It's a highly inelastic good, and people will continue to smoke. And so people are not responsive to that, which means it doesn't really work as an instrument, because there's no link between tobacco taxes and health through smoking. And so it can fall apart as an instrument. The Scrabble score example leading to labor market success, this is trickier, because can you tell some other story of having a weird, complicated name compared to 1930s America that then leads to labor market success? That nobody's really found another path outside of Americanization and integration into society. And so that's kind of good proof that that works as a good instrument. People have not been able to disprove that exclusion story. And so it's worked well for that one study. And so that's kind of what you should always do whenever you see somebody using an instrument. Go through that checklist of, is the instrument relevant? Meaning, is there a relationship between the instrument and the policy? And then you want to see if the instrument is exclusive or meets the exclusion principle. And so that means there's a relationship between the instrument and the outcome, but only through the policy. And then finally, you want to see if the instrument is exogenous, if no other nodes are pointing into it. There's no arrows going into that black dot over there with the instrument. It's just kind of all by itself, a weird exogenous thing that just happens. If you can meet all of those things, then you have a good instrument. If you're reading a paper about an instrumental variable and you can see that it meets all those things, then you have a good instrument. If it doesn't, then that's where you complain about the person's research design in a seminar and complain about it and fight about it. So that is how you define instruments.